Hello and welcome to R.7. It's called rational expressions, but what that means is that we are talking about fractions. All right, so we're going to talk about simplifying rational expressions. When you have often a trinomial, we're going to reduce to lowest terms by factoring and then canceling any term that is common to both the numerator and the denominator, okay? If you can't factor it, it's just called prime. Then we're going to multiply some rational expressions. Then we're going to add them or subtract them. And finally, dividing them, okay? Now, I know that this feels like a lot in the first week of class. I just want to reassure you that the review unit is, it covers a lot of material. This material is disconnected, like each lesson feels disconnected from the previous lesson. So we're just covering an enormous amount of material very quickly. So if you feel overwhelmed, give yourself time to get into the mentality of algebra, okay? But definitely you're not wrong when you're feeling just tired of this. And when you're wondering why is every video an hour long when this is just a 3-credit class. And it's just a lot to review. I'm teaching in pretty detail, but if you don't need it, you don't need to watch everything. Watch what you don't know, watch what you need to learn, okay? So let's get started. In that spirit, let's get started. We have a numerator, we have a denominator. They're both trinomials and we want to factor them so that we can cancel anything that is common to the top and the bottom. All right, let's move down here. Here we have 8x y to the 5th over 4x to the 3rd y to the 4th. Let's just talk about what factoring might be. The factors of 8, if we were going to go to like the most simple factorization we can, that would be, well, let's not go to our simplest, let's just go to most useful. So 8 becomes 4 times 2, x remains x, and then there are y to the 5th becomes y times itself 5 times. I'm so annoyed. Put one of them up here. Do we agree? 8 is 4 times 2, x is x, y to the 5th is 5 y's, 1's in front. 4 is going to remain 4 because that's the most convenient to me. X to the 3rd is 3 x's. Oh no, and then y to the 4th is 4 y's. 1, 2, 3, 4. Good? That's what we mean by factoring something. What you'll see is that 4 can be canceled because it is common to the top and the bottom. One of the x's can be canceled because it's common to the top and the bottom. This y can cancel with this y can cancel with this y can cancel with this y, and this y can cancel with this y, leaving us on the top 2y, both our x's, or sorry, our 1x got canceled, our 8 became a 2, and on the bottom we just have 2 x's or x squared. All right, another way to factor 8 would be to factor it as 2 times 2 times 2. That's called the prime factorization because you can't reduce 8 to anything further than 2 times 2 times 2. Then 4, instead of just remaining 4, would be 2 times 2. And in that case also, this 2 cancels this 2, and this 2 cancels this 2. I just skipped that step because I thought it would be easier to understand as 8 divided by 2 is 4, and 4 is already 4. Either way, you get 8 divided by 4 is 2. X divided by x to the 3rd is x squared on the bottom. Y to the 5th divided by y to the 4th is just 1y. All right, so that's what we're doing by factoring. Let's do this one because this is a trinomial, and down here we have a binomial. So 6 minus x on the bottom, x squared plus 2x minus 48, we want to change it to 2 binomials. Remember our factoring practice, and in our factoring practice, what we said was we want it to multiply to equal a times c, and we want it to add to equal b, ax squared plus bx plus c, right? Multiply to equal 1 times negative 48, add to equal 2. What are our factors of negative 48. You also want to look at these three numbers and make sure there's nothing that can factor out. If this was a 2x squared plus 2x minus 48, you could factor out the number 2, right? But we can't here. All right, so negative 48, but we want the answer to be positive. So I could say it's positive 1, negative 48, right? Positive 2, negative 24. I'm just going to go with only the, oh, I'm sorry, it's positive 2. So I want to go with negative 1, positive 48, negative 2, positive 24. I'm going to keep the smaller number as the negative one because my, it needs to add to a positive number. So my bigger number needs to remain positive. Can you take 48 and divide it by 3? Yeah, you get 16. So negative 3 and 16 divided by 4, you get 12. So negative 4 and 12. And this is what we're going to be doing a lot of today. You can't divide it by 5. Can you divide it by 6? 48 divided by 6, you get 8. So negative 6 and 8. And when you think about negative 6 and 8 and combining them, you do get 2. So this is the one that fits for adding to our b. That means x squared plus 2x minus 48 becomes x minus 6, x plus 8. Okay, that's how I simplified this trinomial into two binomials. Okay, just like we practiced in R4. Now, can I cancel x minus 6 and 6 minus x? It looks a lot like this, x minus 8, 8 minus x. What does this mean? Are these the same, right? X minus 8, 8 minus x. X minus 8, I'm going to line them up better, okay? That's a negative x, that's a positive 8. So I have the right numbers, but this one's positive, this one's negative, this one's negative, this one's positive. What I need to do is multiply times a negative 1. If I multiply the bottom times a negative 1, ooh, no, you know what I'm going to call it? I'm going to call it factoring out a negative 1. Because that's what we've been doing in previous classes. I'm going to factor out a negative 1 just from the bottom. All right, so now that becomes x minus 8 on the top, and then I have a negative 1 factored out of negative x divided by negative 1 is a positive x. Positive 8 divided by negative 1 is a negative 8. So do you see how, because I factored out a negative 1, I got the same term on the top and the bottom? They used to have opposite signs. The x was positive, the x is negative, the 8 is negative, the 8 is positive, but I factored out a negative 1. Now I can cancel. If you have the exact same factor on the top and on the bottom, just like 4 and 4, you can cancel it. Now this is just negative 1. If there's nothing on top, you just put the number 1 on top, okay? What is 1 divided by negative 1? It's negative 1. Just like we could have factored out a negative 1 on top, negative 1, and then this would have been negative x plus 8, which would have matched the bottom, and we would have had a negative 1 on top, positive 1 on the bottom. Negative 1 divided by positive 1 is also negative 1. Either way, this factors to a negative 1. Okay, so what I want to do here, sorry, I jumped from here to here. Before finishing this one, we went to here because I felt like x minus 6 over 6 minus x looked like this situation, so I wanted to address this situation. So let's talk about what to do here. I'm going to rewrite it with a different color because we're getting confusing. I feel confused. X minus 6, x plus 8, divided by 6 minus x. I'm going to put it in order of, in standard form, so order of exponents. This is x to the first power, this would be x to the 0 power, so this goes in front, okay? Now, just like I did here, I'm going to divide by negative 1. So that means I have x minus 6, x plus 8. That negative 1 has been divided out. 1 second. That negative 1 is now a factor of negative x plus 6. Negative x divided by negative 1 becomes a positive x. Positive 6 divided by negative 1 becomes a negative 6. So instead of a negative x plus 6, I have negative 1 times x minus 6. That means just like x minus 8 and x minus 8 factored out or canceled, x minus 6 and x minus 6 cancel each other out. And what I have left is x plus 8 divided by negative 1, right? Any number, pretend like it's a 100, all right? Divided by negative 1 just makes it a negative number. So we're going to say it is negative x plus 8. Sorry, you couldn't see that. Or if you distribute that, you can say it's negative x minus 8 because those are the same answer, okay? So I guess I should have started with these bottom three. Now moving on to the x squared plus 6x plus 9. Again, what we're doing is we are factoring a, b, c, right? Here, a is 1, b is 6, c is 9. We need it to multiply to equal a times c. We need it to add to equal b. A times c in this case is 9. We want two numbers that multiply to equal 9 and that add to equal 6. We're focused on this one. Good. All right, what numbers multiply to 9, add to 6? Oh, well, that's easy. It's a plus 3 and a plus 3, right? 3 times 3 is 9, 3 plus 3 is 6. So I'm going to change this from x squared plus 6x plus 9 to x plus 3 times x plus 3, which we can also call x plus 3 squared. Okay, but since we're trying to cancel things, this isn't the best way to put it. It's easier to look at this way. Then we're going to go x squared plus 5x plus 6. Good. All right, for x squared plus 5x plus 6, we need it to multiply to equal a times c, add to equal b. A times c is just 6. B is 5. So it needs to multiply to equal 6, add to 5. 1 and 6, no. Negative 1, negative 6, no. 2 and 3, yes. Good. So x squared plus 5x plus 6 becomes x plus 2, x plus 3. Just like over here, it became x plus 3 times x plus 3. Now we want to cancel anything that is common to both the top and the bottom, the numerator and the denominator. X plus 3 and x plus 3, they are common to both. So our final answer for this one is, we factored out those factor pairs, x plus 3 over x plus 2. Okay? All right. Next one, x squared plus 4x plus 4. That color idea seemed to be working. So x squared plus 4x plus 4, multiply to equal a times c, which is 4, add to equal b, which is also 4. What numbers multiply to equal 4 and add to equal 4? The numbers 2 and 2, right? So x squared plus 4x plus 4 becomes x plus 2 times x plus 2. Good. On the bottom, we have x squared minus 4. So now we don't have a b, right? We have, it needs to multiply to equal negative 4, and it needs to add to equal, You could say 0, right? Do you have any factors of -4 that if you add them together, you get 0? -2 and +2, right? So x squared minus 4 can be factored as x plus 2, x minus 2. Great. Again, we're going to factor out anything that's common to the top and the bottom, cancel out anything that's common to the top and the bottom after we factored it. And our answer is, this becomes x plus 2 divided by x minus 2. Oh, sorry, you couldn't see that. Good. All right, I'm going to go ahead and not do this one because we don't have any cubes. There's one cube on the homework, but it's not a rational expression. It's just factoring it. And for that, you would want to use the difference of 2 cubes, right? All right, let's go on to this one. X minus x squared divided by x squared plus x minus 2, okay? I'm going to change it, put it in order. Negative x squared plus x divided by x squared plus x minus 2. Okay, before we're even doing something like this where we're trying to change it into 2 factor pairs, what we want to do is see, can I take anything out? Can I factor anything out of x squared and x? So negative x squared plus x. I can divide those both by x, right? So that becomes x. Actually, you know what? I want this to be a positive. So I'm going to divide them both by negative x. So I'm going to take out a negative x so that this first term is positive. Negative x squared divided by negative x leaves me with an x. Positive x divided by negative x leaves me with a -1. Okay? There's nothing wrong with this one being negative and this one being positive. It's exactly like this problem where it's just like sometimes you want it a certain way. And if it's not that way, then you have to multiply or divide by -1. So it doesn't really matter. It's just that when you are lining up a polynomial, you always want your first term to be positive. So since this is a term by itself, and these are 2 terms, I'm going to choose for the leading term of the 2 terms to be positive and the single term to be negative. That's how I made that decision, but it really doesn't matter a whole lot, okay? So that was this one, right? Here it says x minus x squared, but I changed the order, so I said it's negative x squared plus x. After changing the order, I factored out a negative x because I don't want the first term of my binomial to be negative, okay? Now I have x squared plus x minus 2. Let's think about that. We want it to multiply to equal -2, and we want it to add to equal 1. What 2 numbers will multiply to equal -2 but add to 1? The numbers 2 times -1, right? 2 times -1 is -2. 2 minus 1 is 1. So x squared plus x minus 2 becomes x plus 2 x minus 1. Okay, now you'll see that since this is a positive x, this is a positive x, this is a -1, this is -1, we can cancel this. If we hadn't factored out a negative x and we had gotten negative x plus 1, we can just then factor out a -1 and it becomes a negative x times x minus 1, right? So our final answer here is negative x over x plus 2. All right, this time I think I have room on the paper. We're going to perform a multiplication and then simplify the results, leaving our answer in factored form. So again, x squared minus 4x plus 4, we're just going to factor it as best we can. We need it to multiply to equal 4, add to equal -4, right? We couldn't factor, well, first you want to look at it, make sure you can't factor any terms out, right? There's no common terms. What multiplies to 4 but adds to -4? -2 times -2, right? So that is going to become -2. Oh, oh, and I had so little space to work with anyway. Okay. X minus 2 times x minus 2, or x minus 2 squared, right? But we want to write it like this so that it's easier to cancel them out if, by chance, if we're lucky, we can, okay? X cubed plus x. Give that a different color. X cubed plus x can become, what can I do with x cubed plus x? I can factor out a term. I can factor out an x because it is common to both the x and the x cubed. So that becomes x on the outside. X cubed divided by x is x squared. X divided by x is just 1. Okay? All right, next we've got 3x squared plus 3. If we look at 3x squared plus 3, we can factor something out of that. 3x squared plus 3, I can divide both of those by 3. What I'm left with is the 3 on the outside. 3x squared divided by 3 just leaves me with x squared. And then 3 divided by 3 is 1. Good. And then our last one, x squared minus 3x plus 2. I can't factor anything out, but I can try to put it into factor pairs, right? So this means I need to multiply to equal 2, add to equal -3. What numbers will multiply to equal 2 but add to equal -3? -1 times -2. X minus 2, x minus 1. So I went straight to factoring like I was factoring the other page, I think just because I was in factoring mode and I saw things I could factor, but I did not address that this is multiplication. Remember when you're multiplying fractions? So, stop. We're taking the rules of polynomials and we're taking the rules of fractions. The rule for multiplying fractions is you multiply straight across. So after I factored these, now I'm multiplying x minus 2 times x minus 2 times 3 times x squared plus 1 over x times x squared plus 1 times x minus 2 times x minus 1. So it's kind of like that just becomes one big line, right? Multiplication of fractions is just one big fraction. Now I'm going to cancel, if possible, across the fraction bar. I'm not going to rewrite it. It'll take too long. There's an x minus 2 on the top and the bottom, so I'm going to cancel it. There's not a second one. Is there a 3? No. Is there an x squared plus 1? Yes. Okay, cancel everything you can. What are you left with? You're left with x minus 2 times 3 over x times x minus 1. It says leave your answer in factored form. So you don't need to say 3 times x. You don't need to distribute the 3. What you do need to do is put the 3 in front. So I would say that's 3 times x minus 2 divided by x times x minus 1. All right, let's look at 5x divided by 10x plus 5 times 6x plus 3 divided by 5. All right, 5x. Obviously, there's nothing I can factor out. It's only one term. It's monomial. So let's look at 10x plus 5. It's not a trinomial, so it's not going to be two binomials, but 10x and 5. The whole point of highlighting it in pink was to write in pink. 10x and 5, it's a positive. I can divide them both by 5. So 10x plus 5 becomes 5 times 10x divided by 5 is just 2x. 5 divided by 5 is 1. Okay? 5x remains 5x. Multiplication just means you have a really long fraction bar, in my opinion, but 5 we're not going to change, right? Up here we have, I'll do it in blue, 6x plus 3. What can I divide both 6x and 3 by? I can divide them both by 3. So 6x plus 3 becomes 3 times 6x divided by 3 is 2x. 3 divided by 3 is 1. Sound good? Okay. Remember, before I rewrote it, I made sure I couldn't cancel anything. These two canceled, these two canceled. So here, I can actually, in fact, cancel 2x plus 1, 2x plus 1, 5 and 5. Okay? Even though that's called 5x, it's actually 5 times x, so those are two separate factors. That means on the top, I just have a 3 and an x. On the bottom, I have a 5. All right, so that is for multiplying fractions because a over b times c over d is ac divided by bd, right? When we are, however, adding or subtracting fractions, what we need is we need a common denominator. If you don't have a common denominator, you have to create a common denominator via multiplying, right? Okay, so 2x squared plus 6x plus 3x plus 4, but they're being divided. So it's 2x squared plus 6x divided by 2x minus 3 plus 3x plus 4 divided by 2x minus 3. Thankfully, they have the same denominator. So what we can do for our first one is all of those terms on the top just get added together. Plus 3x plus 4 because they have the common denominator, and so they are all over 2x minus 3. We don't multiply the denominators together, we don't add them together, we just keep the same denominator. Okay, now just combine like terms. 2x squared plus 9x, right, because 6x plus 3x is 9x, plus 4 over 2x minus 3. Now you still want to make sure though that you cannot factor out a 2x minus 3 from the top. Good? So what is 2x squared plus 9x plus 4? Multiply to equal 4 times 2, which is 8. We need it to add to equal 9. So we're just making sure we can't make any factor pairs of 2x squared plus 9x plus 4. Anything that multiplies to 8 but adds to 9, yeah. 8 and 1, right? So, but remember, because this is a 2x squared, the a is not 1. We call that 2x squared. 9x becomes 8x and 1x plus 4. And then we have to do factoring by grouping. 2x squared plus 8x, right? I can divide them both by 2x. So that's 2x. 2x squared divided by 2x is x. 8x divided by 2x is 4. On the other side, we've got plus x plus 4. Those don't actually have anything in common, so we're just going to divide them by 1. Plus 1. X divided by 1 is x. 4 divided by 1 is 4. This, so we're talking about 2x squared plus 9x plus 4 becomes x plus 4 times 2x plus 1. So that's this is the factored form of this. So it's going to be, as our final answer, x plus 4 times 2x plus 1 divided by 2x minus 3. So there wasn't anything I could divide out, but you do need to leave it in factored form so that you can check that you can't factor anything out. Okay? All right, here we have 6 divided by x minus 1 plus x divided by 1 minus x. So let's talk about this again. This problem, these need to be the same. 2x minus 3, 2x minus 3. sorry, 2x minus 3, 2x minus 3, common denominators. That side works. This side doesn't because it's x minus 1, 1 minus x. But what do we do when we see something like that? We look for our first example. X minus 8 divided by 8 minus x is just negative 1. So what we do is we say this is going to be multiplied by negative 1. So our second problem, 6 divided by x minus 1 plus x divided by, instead of calling this 1 minus x, I'm going to call this negative x plus 1. Okay? These are close, so now I'm going to say that this is 6 over x minus 1 plus x divided by, remember, negative 1, negative x divided by negative 1, and positive 1 divided by negative 1, all right? Because here's that negative 1. Negative x divided by negative 1 is x. 1 divided by negative 1 is a negative 1. Good? 6 divided by x minus 1 plus x minus 1, right? That negative sign, I'm now going to move up to the x because it doesn't matter, right? It really doesn't matter. Let me show you. Negative 1/5 is the same as negative 1 over positive 5 and is the same as 1 over a negative 5. Those all mean the exact same thing. So there was a negative 1 down here, but I need these to be common denominators, so I'm just going to move the negative up here because I can move the negative sign around. It doesn't change the value of the fraction or of each part of the fraction. It's just that there is a negative being divided by a positive or a positive being divided by a negative, okay? In fact, if you have something like x minus 7 over x plus 5, and you want to say that it's negative, that's the same as saying there's a negative x minus 7 over x plus 5, or it's the same as saying there's an x minus 7 divided by a negative x plus 5, which is also the same as saying there is a negative x plus 7, like I'm distributing it, right, over x plus 5, or that there's an x minus 7 divided by a negative x minus 5. 1, 2, 3, 4 ways to write negative this. All right? So now that I've moved my negative sign, just the sign, it's called a 1, but it's a sign, the negative sign from the bottom to the top, I now have common denominators. So it's okay to manipulate your fractions a lot to get a math problem that you can work with, okay? So now our common denominator is x minus 1, and on the top we're going to combine the x minus, the 6 minus x. So our final answer is 6 minus x over x minus 1. Good? All right, third example is 3x divided by x minus 4 plus 2x divided by x minus 3. Good. Here, we need common denominators and we do not have them. What you need to do when you need common denominators is that you have to multiply this denominator by both the top and the bottom of this fraction and this denominator by the top and the bottom of this fraction. So this x plus 3 is going to be multiplied on the bottom and on the top over here. And then this x minus 4 is going to be multiplied on the top and the bottom over here. Good. So now we have 3x times x plus 3 plus 2x times x minus 4. And on the bottom, what it's done is said that we have x plus 3 times x minus 4 as our common denominator. Okay? We cannot, unfortunately, say that this and this cancel out and this cancel out because of this plus sign. You can only cancel out things that are being multiplied, but because there's a plus, this is all one thing. So what we want to do is we want to simplify 3x times x plus 3 plus 2x times x minus 4. 3x times x becomes 3x squared. 3x times the 3 becomes 9x. 2x times x is 2x squared. 2x times a negative 4 is a negative 8x, divided by that same x plus 3, x minus 4. It says leave it in factored form, so I'm not going to change the bottom. 3x squared plus 2x squared becomes 5x squared. 9x minus 8x just becomes plus x. X plus 3 times x minus 4 on the bottom. You could factor out 1x, so then it's just 5x plus 1. X plus 3 times x minus 4, I would say, is my final answer for that one. Good. And same thing with this last example. We have x divided by x squared minus 1 minus 1 over x. We need these denominators to be common, so I'm going to multiply the top and the bottom here by x. I'm going to multiply the top and the bottom here by x squared minus 1. Good. Now we have a bottom in common, x times x squared minus 1, leaving it in factored form. X times x becomes x squared minus 1 times x squared is x squared. Negative 1 times negative 1 is plus 1. So I just have 1 over x times x squared minus 1. Finally, complex rational expressions with you're taking fractions and you're dividing them by fractions, okay? This is an intimidating way to look at them, but another way to look at them is to think of them as 1/3 plus 2 over x for this first one, right, is being divided by x plus 4 over 6. What do we do when we have division of fractions? We keep flip change. So that first term, we keep 1/3 plus 2 over x. Flip this one, 6 over x plus 4, and change it to multiplication. Okay, so if you want to get rid of the division sign, you can either write it like this or you can change it to multiplication. Now, when you do that, when you look at the division and the multiplication, which one looks easier? A denominator of 3, x and 6, or 3x and x plus 4? Honestly, this one still looks easier, right? So I'm not going to turn it into a multiplication problem, even though it did look easy. It's not because of that plus sign, okay? So instead, what I want to do is leave it as a division sign. It's easier to look at long ways for me. And I want to get rid of all of the denominators. I want to get rid of the 3, the x, and the 6, okay? What is a common denominator of 3x and 6? I'm going to multiply everything by, it's okay to multiply everything by 3 times 3 times 3 times 3 times x times x times x and times 6 times 6 times 6. But if we just multiply by 6 and x, it will cover the 3, right? Because 6 is just 2 times 3. So instead, we're going to say 1/3 plus 2 over x divided by x plus 4 over 6. And we're going to multiply all of these by 6x, 6x, 6x. Okay, because 6x divided by 3 is going to get rid of the 3. 6x divided by x is going to get rid of the x. 6x divided by 6 is going to get rid of that 6. 1 is being divided by 3 and multiplied by 6x. 6 divided by 3. I can put that into my calculator. 6 divided by 3 is 2. So that becomes 2. And then I still have that x times 1, but anything times 1 is itself, right? Plus 6x divided by x. I lose the x and I just have 6 times 2. Here, I'll add them. That was a 1. This one's a 2. And then we're saying divided by 6x divided by 6. The 6's cancel, and I just have x times x plus 4, right? That should be green. The x plus 4 should be green. I was creating a pattern. Good? All right. 2x times 1 is just 2x. 6 and 2 is 12. I'm going to distribute that x. X times x is x squared. X times 4 is 4x. Okay, so now I have the quantity 2x plus 12, and now it's easy to look at it vertical again. This was horizontal, now it's vertical again. X squared plus 4x. What can I pull out of both of those? They both have common factors. 2x and 12, I can pull out a 2. 2x divided by 2 is just x. 12 divided by 2 is 6. Down here, I can pull out an x. X squared divided by x is x. 4x divided by x is 4. Oh, sorry, you couldn't see that at all. So that is the factored form of that, okay? We didn't need to change it to multiplication, but I do like writing it this way because it's easier to see what the denominators are. If you're not going to look at it that way, just remember that the bottom, so there's the bottom of the big fraction, but the 3, the x, and the 6 are the bottom of the interior fractions. You want to get rid of those first, all right? Here we have 1 minus x divided by x plus 1 over, or divided by 2 minus x minus 1 divided by x. Again, I prefer to write them horizontally. So we have all of 1 minus x over x plus 1, and it's being divided by 2 minus x minus 1 over x, right? What kind of denominators am I dealing with? I have an x plus 1 and I have an x. These two don't have denominators, right? So I'm going to multiply everything by x times x plus 1. X times x plus 1 times 1, right? Minus that same x times x plus 1 times x over x plus 1 divided by x times x plus 1 times 2 minus, x times x plus 1 times x minus 1 over x. Okay, so that's all of it, but now I'm getting rid of the x plus 1 and I'm getting rid of the x. Here, 1 times x plus 1 is just x times x plus 1. This cancels with this, so then I have minus x times x, right? Orange x and black x. Divided by x times x plus 1 times 2. That's just going to be 2x times x plus 1 minus This cancels this, and we have x plus 1 times x minus 1. Good? Okay, so that becomes x. Because of this minus sign, I cannot factor anything out, right? I need to instead use the distributive property to simplify, see if I can cancel anything out in this itself. X times x is x squared, x times 1 is x, minus x times x is x squared, okay? Divided by 2x times x is 2x squared, 2x times 1 is 2x, minus, okay, x times x is x squared, x times negative 1 is negative x, 1 and x is x, 1 times the negative 1 is negative 1. Notice that I started and closed the parentheses but after the minus sign because I have to subtract all of that, all right? X squared plus x minus x squared, those cancel and I just have x, right? Divided by 2x squared plus 2x, distribute that negative, minus x squared plus x minus x plus 1. Good. Combine like terms. 2x squared minus x squared is just x squared. 2x and x minus x. Well, x minus x cancels itself out, right? And that's plus 2x plus that original 1. So we have x divided by x squared plus 2x plus 1. I'm not going to be able to factor out an x, but it did say leave it in factored form. So is there anything that will multiply to equal 1, but add to equal 2? Yeah, it's just x plus 1, x plus 1. So it's actually x divided by x plus 1 squared would be the factored form of that. Okay, last thing, this video is already way too long. I just want to show you that this problem, which you will see on my math lab, is the same as, oh my gosh, I turned off my recording. It's the same as this problem, okay? This is a division problem. This was a multiplication problem, but we broke it all down and we canceled things out. What's the difference between division and multiplication? It is that this one is 3x squared minus 11x minus 20 over 3x squared plus 5x minus 8 divided by 9x squared plus 24x plus 16 divided by 3x squared plus 11x plus 8, right? And so to divide that, we're going to flip it and multiply. So that's 3x squared times, this one's now on the bottom, this one's on the top. And now you're just going to break them down like, just like we did this one, okay? Do email me though if you want me to see it. I'll happily make you a video and email it to you. All right, thank you so much. I know that was a long one. You're gonna do great.